Hey there. You know that feeling when you're staring at a massive project plan and you're just wondering, when is this actually going to be done? Well, today we're going to break down a really powerful technique to figure that out. So let's jump right in and learn how to calculate a project schedule using something called the forward and backward pass.
This is really the core question we're trying to answer. It's not about guesswork or, just crossing your fingers and hoping for the best. It's all about using a structured method to find a real, solid finish date. And maybe even more importantly, it's about understanding the flexibility, or the lack of it, for every single task along the way.
All right, so here's how we're going to tackle this. First, we'll look at a little scheduling puzzle. Then we'll lay it all out in a network diagram. After that, we'll do the forward pass to find the earliest times, and then the backward pass to find the latest times. And by the end, we'll have the complete picture. Okay, so before you can schedule anything, you really need to know three things. First, what are the actual tasks? Second, how long is each one going to take? And third, what are the dependencies? Now, dependencies, they are the absolute heart of this puzzle. They're basically the rules of the game, the things that say, hey, you can't start this task until that other one is finished. So to make this all make sense, we're going to walk through a real example project from the very beginning to the end. Let's take a look at the tasks we're dealing with. All right, here's our project. It's broken down into 8 activities, which we've just labeled A through H. The duration column, that's pretty straightforward, right? It just tells us how many weeks each task is going to take. But this precedence column, this is absolutely crucial. It's the one that tells us what has to be done before a task can even start. So for instance, you can see right there that activity C, it literally can't begin until activity A is all wrapped up. Now, a table like that is useful for sure, but a diagram makes the flow of the project so much clearer. So what we do is take all that info and we build what's called a precedence network. Time flows from left to right, from start to finish. And you can see all the relationships instantly. You can see how some tasks can happen at the same time in parallel while others are stuck waiting. This diagram, this is going to be our blueprint for everything we calculate next. All right, now for our first big calculation. This is called the forward pass. And the goal here is actually pretty simple, but it's super powerful. We want to find the absolute earliest time that each and every activity can possibly start and finish. So yeah, that's the formal definition. We're basically working our way forward through that network from start to finish to figure out the earliest possible timeline. Think of it like this. It's the most optimistic schedule you can have, but one that's still totally realistic based on the tasks and their durations. Okay, let's do this. We're going to start at week 0 and just move from left to right across the diagram. The logic is actually pretty easy. For any task at the very beginning, with no tasks before it, the earliest start is 0. Makes sense, right? And its earliest finish? Well, that's just its start time plus how long it takes, its duration. But here's where it gets interesting. What about a task that has a couple of predecessors, like activity H? See how it can't start until both C and D are done? So which one do we follow? The rule is you always have to take the later of the finish times. Activity H has to wait for the last thing to finish before it can start. And if we just follow these simple rules, we can work our way right across the whole network. And voila, here are the results. If you look now, every single box has its earliest start and earliest finish time filled in. We've just systematically built out the absolute best case scenario schedule. And what this shows us, crystal clear, is the earliest possible time the entire project can be finished. So here's the big takeaway from all that. The project's earliest finish time is always determined by the very last activity to be completed. For us, if you look at the diagram, that's activity G, which wraps up at the end of week 13. So what does that mean? It means the absolute earliest this entire project can be done is in 13 weeks. Not 12, not 11, 13. Okay, knowing the earliest finish time is awesome, but it's only half the story. What about flexibility? Do some tasks have any wiggle room? Well, that's exactly where the backward pass comes in. We're now going to do the exact opposite. We're going to work in reverse, starting from that 13-week deadline to find the absolute latest an activity can start or finish without messing up the whole project. Yeah, this is really the other half of the puzzle. The backward pass is all about finding the drop-dead deadline for every single task. It's what tells us our wiggle room, How long can we put off starting a task before it starts to cause a major problem for our final deadline?
So to do this, we plant our flag at the end of the project, at week 13, and we start working backwards, from right to left. We set the latest finish for the very last activities to 13. Then to get the latest start, we just subtract its duration. Now here's the key rule, and it's the exact opposite of the forward pass. If a task comes before a bunch of other activities, its latest finish time is the earliest of the latest start times of all the tasks that come after it. It's a little tricky, but if we just apply that logic all the way back to the start, we'll get our answers.
And there it is, the complete network. Now, every single activity has 4 super important dates attached to it: earliest start, earliest finish, latest start, and latest finish. This gives us the full timing profile for our entire project. It's all there.
So let's step back for a second. What does this complete picture really tell us? I mean, we started with just a simple list of tasks, right? And now look what we have: a rich, super detailed schedule with clear time boundaries for every single step. I mean, just look at the difference here. On the left, that's where we started, a plan with a lot of question marks. On the right, that's where we are now, a schedule with actual intelligence baked right in. Just by running these 2 simple calculations, we've literally transformed a basic flowchart into an incredibly powerful project management tool.
And really, this is the ultimate takeaway. For any single task in our project, we now know its absolute earliest start date and its absolute latest start date. That range between them, that's its scheduling window. And as long as a task starts and finishes somewhere inside that window, our big 13-week project deadline is totally safe. So, I'm going to leave you with this one last question. If you look closely at that finish diagram, you'll see that some tasks have a gap between their earliest and latest times. They have that wiggle room we talked about. But some of the other tasks have the exact same earliest and latest times. So what does it mean when a task has 0 flexibility? Absolutely none. Well, that is the key to the next and maybe the most crucial step in project scheduling, but that's a story for another time.